Samples and markers are loaded into wells at the top of the gel. A running buffer is added. As electric current runs through the buffer, the negatively charged proteins migrate towards the anode. The polyacrylamide gel contains a stacking layer on top of a resolving layer. The stacking layer, which has a percentage T of around 4%, contains much larger pores than the resolving layer. Proteins tightly stacked like coins in order of decreasing mobility migrate through the stacking layer. At this stage, mobility of the proteins depends on the electrophoretic conditions. Because of the drastic difference in pore size, once the protein stacks reach the resolving layer, the proteins begin to separate according to size. Because small proteins experience less resistance as they move through the pores, they move more quickly than larger proteins. The dye front consists of a very small dye molecule, like bromophenol blue, which is mixed and loaded with the sample proteins. Because of its small size, the dye front moves ahead of the proteins. The position of the dye front is a good indicator of how far the proteins have progressed through the gel. Electrophoresis is complete once the dye front reaches the bottom of the gel.